All right. When you're looking at, if I look at a graph to solve an equation, then what's the solution to this equation? None, right? We would say there's no solution. I tried to get you into the new habit of saying that there's no real solution because it doesn't cross the x-axis. But the reality is, mathematically, it makes sense to talk about an imaginary solution. Okay? Let's think about a different way of doing this. If I were to attempt this problem, a different method, not using graphing. I mean, clearly by graphing, it's no solution, right? Let's try a different method. I'm not sure if you can read it, but it says y equals, or I can just go ahead and call that 0, equals x squared minus 4x plus 5. How would you attempt to solve this one? Is it factorable? All right. We already know it's no solution, so it's not factorable, right? Okay, so it doesn't factor. Nothing will multiply to give you 5 and add to give you negative 4. I can try any method you want to try. What do you want to use? Let's be quick about it. It's either completing the square or... All right, complete the square. So that's going to be subtract the 5. Oh, sorry, wrong side. So that's going to be negative 5 equals x squared minus 4x. Let's complete the square. In our head, we're going to take this, divide it by 2, and square it, right? So divide that by 2. That's going to be plus 4. And over here, I've got plus 4. That does make it perfect. So now I've got, what is that? Negative 1 equals parentheses x minus 2 squared. Double check me here. Is that right? Okay. And then when I try to square root both sides, here's where I come across an issue. Okay? If you're just in a super hurry and you're flying along, you would say this, plus or minus square root of negative 1. But that presents a huge problem. It's the one Amanda mentioned earlier, right? I think it was somebody, Lindsay did. All right? We don't know how to do this, right? We don't know how to do the square root of negative 1. So as of right now, we would stop right here and we would say, whoa. Say it. Whoa. Good. All right, no real solution. And that makes sense, right? Because the graph never touches the x-axis. The graph doesn't touch the x-axis. I'm trying to do the square root of a negative. Both of those things, they don't make sense, right? All right. There is a way to deal with it. We're not going to go into a lot of super details about it, but I'm going to give you a quick definition, and we're going to play around just a little bit with what we call imaginary numbers, okay? So we're going to come back to this problem, and we are going to finish this problem, okay? Somebody remember this part for me because I probably won't get it back, okay? All right, here we go. Imaginary numbers are defined. Imaginary numbers are defined as this. The square root of negative 1 equals I. Of course, little I stands for imaginary. Okay? So it's kind of like pi has its own symbol, right? There are a lot of different symbols we use to represent very special numbers. Well, I represents an imaginary number. Okay? So this is an imaginary number. Is it possible for a number to equal the square root of negative 1? No, and that's why it's defined as such. So if I see square root negative 1, I'm going to have to call it imaginary. But guess what? It still follows all the same rules that we have with regular numbers. And it works. Now, we're only going to play with just the easiest parts of it today, and next year you'll deal with more complex numbers. They're actually called complex numbers. But just look at this problem here. Square root negative 4. Now, 4 is perfect, right? So if I didn't have that stinking negative in there, I could do the square root of negative 4. I could do the square root of 4, right? So what I want to do is I want to think, just like we've been simplifying radicals, can you rewrite this as square root of 4 times the square root of negative 1? Is that fair to say that? Just like we were simplifying radicals? Well, why would that be nice?
Because then you had two square root.
Okay, I can really do the square root of 4, can't I? That's perfect. So now I can take care of this guy. That's a 2. Okay? And now think about this new definition I just gave you. What is the square root of negative 1? So anytime you see the square root of negative 1, you can take it out and put what in its place? My answer is 2i.
Is it just for negative?
Just for negative 1. So the simplest way to write the square root of negative 4 is for me to say 2i. In other words, 2 times some imaginary number will give me the square root of negative 4. Okay? Now, it doesn't make a lot of sense to you, but mathematically it works, and that's the real key of what we're looking at here. I can take this number, if I come across an imaginary solution, like on that last problem, I can plug it back in and it would work. And if it works, it's a solution, right? That's what makes something a solution. Hey, all we're doing, guys, like I said, we're just barely touching the top of this, so we're just playing around a little bit. Let's look at this square root negative 24, kind of do the same idea. What would we do to clean this up? Square root negative 24. Okay, I'm going to do, let me change colors here. How could I clean up the 24? Okay, 4 and 6, probably the best way, right? And what about the negative? Negative 1. Okay, so I'm going to break it up into 3 pieces. I like the square root of 4. What is that? That's a 2, so that becomes 2. Can't do anything with the square root of 6, can I? Okay, so I'm going to have to leave that square root 6. Now, what is this? What is my new definition? The square. Anytime I see the square root of negative 1, what do I call it? The letter I. So I can put that letter I right there. My answer would be 2i square root 6. Yes, ma'am. All right, we'll try this guy. What does your gut tell you from what we've been practicing at the beginning of class? What would you do with the 12 and the 3? Negative 12 and the 3. Okay, you could. You absolutely could. Break it up into 3 and a 4. But you know what? Since neither one of them are perfect now, might as well put them together. Because right now they're not perfect. If I put them together, at least there'll be one number. Maybe it's perfect. Maybe it's not, but at least it's 1 instead of 2, right? So why don't we do this? Why don't we do negative 36? Negative 12 times 3 is negative 36, right? Now that ended up being nice, didn't it? Because 36 was perfect. So I'm going to go another step. I'm going to break that down into square root 36 and square root of negative 1. And I can simplify both of those. Square root of 36 is just plain old 6. And the square root of negative 1 is the letter I. It's imaginary. All right, those are all dealing with square roots. Let's multiply. It's probably the 2 easiest kinds of things you can do with them. Your gut instinct. Tell me your gut instinct on what to do to simplify these guys right here. Does everybody have this? I'd like to have a little more space to write. Everybody got what you need? All right. All right. Tell me your gut instinct on this right here. 3i times negative 2i times 5i. Multiply. It's multiplication, right? So there's no combining like terms. It'd be multiply. So how about 3 times negative 2 times 5? Does that make sense? What's 3 times negative 2 times 5? Negative 30, right? Maybe, okay, maybe you said it. Maybe I just didn't hear you. Negative 30. What does your gut tell you? I times I is? I to the third power, right? I mean, I times I. You would never write it like that. You would write it I to the third power. Okay? Almost. Almost. Okay? When we do things in simplest imaginary form, that's really not a term, but if I simplify things down to imaginary land, I like to just stay in the I squared or I land. Okay? So here's what I'm going to do. I to the third becomes, there's my negative 30, I to the second times I. You okay with that? This is not doing what I want it to do. Are you okay with that?
Wait, is that second 30? Is that negative in front?
That's still a negative. Yeah, I'm sorry it didn't. All right. But I to the second and I is that's really this, right? Because you add exponents together. Okay. Why do I like that? Go back up to the top. What is I squared equal to? So can I take an I squared out and put a negative 1 in its place? So right here, I'm going to take this out and put negative 1 in its place. And what's negative 30 times negative 1 becomes positive 30, doesn't it? My answer is positive 30I. I want my answers to just have a single I in it or nothing. If I have no I's, that's even better, isn't it? Except if there's no I's, then it's real. Okay? But if I have to talk about imaginary numbers, I'd rather it be with a single I. Okay? Now, like I said, there's way more rules to all of this. There's way more tricks and stuff like that. We're just really touching the top. Okay? Yes? I to the 10th. I need to simplify that. It's 5I squareds. Does that make sense, what he said? I to the 10th is the same thing as, I'm going to do it the long way. You can do it the short way. I'm going to say it's the same thing as I to the second times I to the second, I to the second, I to the second, I to the second. That's very ugly. Sorry about that. But is that true? All of these together do give me I to the 10th, don't they? Why are those nice? Because each and every one of those I to the seconds is really negative 1. So I'm going to go through and make that a negative 1. And make that, this is all multiplication, a negative 1. And make that a negative 1. And make that a negative 1. And make that a negative 1. And what's my answer? I got negative 1 times negative 1 times negative 1 times negative 1 times negative 1. My answer is negative 1. Look what happened. I could take an imaginary number and end up with a real answer. Okay? Just playing around, guys. I promise you. Don't worry too much about this. We're just playing around with a new concept. What about I to the 7th? Take the same concept and go with I to the 7th. I to the 7th would really be I to the 2nd times I to the 2nd times I to the 2nd times I. Just a single I, right? Okay. Well, what are each of those I to the seconds? That's a negative 1. That's a negative 1. This one's a negative 1. But then there's still that lonely old I. Right? So what does all that equal? Negative 1I, or just negative I. Okay? Like I said, now, like I said, this is playing around, okay? It really is playing around. I's are neat to play with, especially for what we're going to do with it, okay? When you get into other stuff, it's a real pain in the rear, but for what we're going to do, they're fun to play with, okay? All you're doing is playing with I and I times I. If you got an I, it's square root negative 1. If you got I times I, it's square root negative 1 times square root negative 1, which is square root 1, which is 1. All right? You can play around with it a lot, okay? This looks like a lot. It's not. There are two problems to solve using the quadratic formula, which will give you imaginary answers. There are two problems to solve completing the square, which will give you imaginary answers, okay? But before you get to those, this is playing around with I, okay? Go to it now. Let's look. I'll help you with 1 through 8 right now, and then you can be on your own. But go ahead and go to it now. playing around, guys. Just playing around.
Jim.
What?
We didn't get it right down.
Right, Pastor. Okay, so let's play around. I've got square root negative 81. You recognize 81 is perfect, right? So rewrite it as square root 81 times square root negative 1. So what's my answer? 9i. That's right, it's 9i. Not too bad. What about number 2 right over here? 32 is not perfect, is it? So let's do a little simplifying. What'll give me the 32? Okay, 16 and 2. And what about the negative? Make that negative 1. Okay. The square root of 16 is 4. The square root of negative 1 is I. And I'm left with the square root of 2. So 4i square root 2. Number 3, this is a multiplication problem. So I got 4 times negative 3. Negative 12, no problems. What about I times I? That's I squared. But I squared has its own definition. What was the definition of I squared? Okay, I squared is negative 1. So instead of saying 12 times I squared, I'm going to say 12 times negative 1. What's 12 times negative 1?
12.
Positive 12. So that's kind of a neat little thing that happens if you multiply an imaginary number times this imaginary number, you end up with a real number. How weird is that? All right. 4 is the same kind of idea. A little bit uglier. I hope I got enough room for it. Let's try that over here. Let's see. 3 times 2 is 6. That's the first thing I'm going to do. And then square root of... That's not going to be nearly as bad. What's negative 24 times negative 18? Say that again, please. 432. But more importantly, it's what? It's positive, isn't it? I don't even, this imaginary number, gone. I don't even have to deal with I, do I? I just got to break down 432. Oh, anybody got an idea? I don't think it's perfect. Try it. Try 21, 22. All right. I could break it down. 16 and 27. 27's got another 3 hidden in it. Try whatever 16 times 3 is. Try that. Does 48 go into it?
48, 90.
But what we want to do on this out of the 40 is we definitely want to look for the pattern. Once we find the pattern, we should be able to figure this out. Let's think for a second. I to the 40 is really I squared, I squared, I squared, I squared. Whoa, I'm not doing that all those times. How many of those are there?
20.
It'd be 20 of those, right? Okay. 20 is an even number, right? Okay. Each of those i's, each of these I squareds is negative 1, right? So that's really a negative 1, and that's a negative 1, and that's a negative 1, and a negative 1. But how many of them are there? 20. So if there's an even number of them, what's the answer going to be? It's going to be positive 1. So you're looking for the pattern. And easily enough, keep the same idea. What would all this be for I to the 63rd?
Negative 1.
Okay, it is going to be negative 1, but And you're right about that as far as the pattern goes. So it's going to be I squared, 60, no, not 60, 31 times, right? Plus one extra I on the end. Does that make sense? So each of those is a -1, -1, -1. But I got 31 of them. So what's that going to be? That's going to be a -1, right? Because this is odd. So that's going to be, all of this is going to give me -1. And then you still got this I. So the answer is -1 I. Like I said, guys, we're just playing around. That's all we're doing. You've got two more right here. What would you do on 7? Subtract the 32. And that gives you 4x squared equals -32. Divide by 4. X equals -8. Oh, sorry, x squared equals -8, right? How do you get the x squared by itself? Square root both sides. So now I know that x is equal to, remember it's actually plus or minus, right? Plus or minus whatever the square root of -8 is. And now I got to play around with the 8 and the -1. 8 turns into 4 times 2, right? So it's going to be 2 square root 2. All right, so that's going to be, I've totally run out of room here, I'm sorry. That's going to be plus or minus 2 square root 2. And what about the -1? It's actually I. Yeah, I left it out, didn't I? It would have been, that's my fault. Plus or minus 2I square root 2. All right, and I've run out of room to help you anymore, but